All right, so welcome this morning to our little video here on section 62, fixed electric heating systems. All right, students, you got to know there's some rules in here that you absolutely have to know. So overcurrent and demand factors being the biggest. So let's just take a look here at the scope. Section 62, this section applies to fixed electric space heating systems for heating rooms and similar areas. So that would include baseboards, etc. Fixed surface heating systems, so imagine driveway type heating, and fixed electric heating systems not covered by A and B, so that pretty much wraps it all up. 2, the requirements of this section supplement or amend the general requirements of this code. Let's go take a look at the Appendix B note here on this. All right. Space heating is the application of any fixed heater technology that results in adding heat to an enclosed space or a room. So think sauna, baseboards, etc., any type of wall-mounted heater. This is normally for increasing the comfort of persons or animals, but could include storage spaces or rooms where it is important to keep stored material above a certain temperature. Some examples of space heating are central heating units, baseboard heaters, radiant heaters, wall and ceiling heaters, and floor warming heaters. The primary purpose of a floor warming heater may be for the comfort of persons walking on the floor, but such heaters are added to heat the room. Note, many heater technologies added to heat a room by convection, conduction, and radiation. Surface heating. Surface heating is the application of fixed heater technology that results in increasing the temperature of a surface. Some examples of surface heating are pipe heating, storage tank or vessel heating, so this is in the industrial type atmosphere, and snow or ice melting on or embedded in a surface, such as roofs and gutters, or embedded in concrete, asphalt, or soil, and similar applications. Other heating systems. Other heating systems are applications of fixed heaters that are not space or surface heating systems. Some examples of these systems are pipe internal heaters, often referred to as gut heating, immersion heaters, and hot water tanks. All right. Terms. 62-102. The term heating cables is being replaced in product standards and international standards with heat trace. Dielectric heating. The operating principle behind dielectric heating is that when an insulating material is placed within a high frequency electric field, molecules are excited by an alternating electric field causing heating within the material. The frequency applied is generally between 1 and 300 megahertz and depends on the material to be heated. This is sometimes called capacitive or radio frequency heating. Impedance heating. The operating principle behind impedance heating is that an applied AC voltage or an electrically conductive object to be heated will generate a current in that object, resulting in direct Joule I²R, sometimes called resistive or ohmic heating within the object itself. There is also some additional heat generated due to impedance effects of eddy currents and hysteresis losses. Note, impedance heating was called pipeline resistance heating in previous editions of this code. Then we have induction heating. The operating principle behind induction heating is that a coil of conductors surrounding an electrically conductive object or running parallel to it creates magnetic flux, induced currents in that object, and results in direct Joule I²R, sometimes called resistive or ohmic heating of the object itself. Eddy currents and resistive hysteresis losses will add to the heat generated. Induction heating is generally applied to line frequencies. For surface heating of pipelines and vessels, see Rule 62-300, and at higher frequencies. Then we have skin effect trace heating. This is why you come to school and you got to learn about Ohm's law and induction and capacitive, because all this stuff You have to understand it so you got an idea when you're installing it. All right, back to the section. So we have our units here, our special terminology, just like in motors. You can read them. And let's get down to terminal connections. Connections to heating devices shall be made in terminal fittings or boxes, and the heating device set shall be installed so that connections between the circuit conductors and equipment device conductors are accessible without disturbing any part of the wiring. That's critical. 2, where the connections described in Subrule 1 are made in terminal fittings, they shall be contained in an enclosure of non-combustible material. 3, where the maximum temperature at the point of connection between branch circuit and a heating device exceeds 60 degrees C, the temperature rating of the conductor insulation shall meet or exceed the temperature rating specified by the manufacturer. So the termination temperature rule, you'll have to look on the heaters because it'll tell you the minimum temperature rating required right in the connection box on heating. 4, where a tap conductor is used to meet the requirements of Subrule 3, the length of the tap conductor shall not be less than 500 millimeters. So they're telling you that, say you run a 90-degree conductor out there, but in that connection box, it requires 110 degrees insulation. They're telling you that the conductor that you moret on to meet the requirements can't be less than 500 millimeters. That brings us to branch circuits. Branch circuits used for the supply of energy to heating devices sets shall A, be used solely for such heating device sets and have an ampacity not less than that of the connected load supplied. 2, for the purpose of this rule, a unit that combines heating with ventilating or lighting equipment or both shall be considered to be a heating device set. So in a bathroom type scenario where you have a fan with a light, etc., that's what they're talking about there in Subrule 2. Then 3, notwithstanding Subrule 1, where a heat lamp is not the sole source of heat, it shall be permitted to be used in a luminaire or in a box mount luminaire where the luminaire is supplied from a branch circuit installed in accordance with Rule 8-304. 62.112, temperature of adjacent combustible materials. Heating devices shall be installed so that any adjacent combustible materials shall not be subject to temperatures in excess of 90 degrees C. All right, so be careful when you're installing this, right? You don't want to cause a fire. That brings us to 62.114, overcurrent protection. We'll do that in the next video.